Welcome back. Hi everyone. So let's go and describe or identify the key feature of a polynomial using its graph. Okay. The degree here is odd because the arrows. I like to draw arrows at the end. Okay. The arrows on the polynomials are uh, are going toward opposite directions. Okay. The arrows are going toward opposite direction. One is going up on the left and down on the right, okay? And what is the sign of a leading coefficient? So the reason why I wrote negative here is because the arrows on the right, the arrows on the far right is going down. Because it's going down, I know that that's a sign that, oh, the leading coefficient is negative. The sign of a leading coefficient is negative, okay? Now let's describe the end behavior. So the end behavior means what is occurring at the ends. So there's two sides to consider, okay? You're going to consider the side on the left side of 0, okay? So this side here represent all the negative numbers. In end behavior notation, you use arrow notation. This is the meaning of all the negative numbers using arrow notation. As x, okay, keeps on going to negative infinity, keeps decreasing, okay, what is happening to the y's? Look at the arrows. The arrow is pointing up, so the y value keep on increasing forever. That's why it was y goes to positive infinity. Next, um, this was on the left. You're looking on the left. So now you want to look on the right. Okay, the right side of 0. So all the number on the right side of 0 are pointing so the number on the right side of 0 are positive number. This means as you move to the right, the x value keep on increasing. So this is made the arrow notation for as the x value for the positive x-axis. This is the orientation. As x goes to positive infinity, y approaches negative infinity. Y, okay, the left side, on the right side, sorry, the arrow is going down. So that's why I would negative infinity. So the y-intercept represents the point of intersection between the polynomial and the y-axis, and the 0, 0. And again, what are the zeros? Which 0 represent the x-intercept, where the y value is 0. And you have two x-intercept. So the first one is from left to right is x equal -2. And we know that this is a double because as you can see, the polynomial is touching the x-axis at -2. It's not crossing over. Okay, so I know it's a double. It's bouncing back up. Now the next x-intercept is at 0. X equals 0. So x equals 0. You see how the polynomial is passing through? I know that because the polynomial is passing through, it's a single root. Okay, and in this straight way. So it's a single root. So now how do we derive the factor form? So because you have a double, the factor is going to be, the double for the factor is going to be, what number do we add to -2 to get a +2? Okay, you're going to be adding 2. And you end up with x plus 2 equals 0. Okay, and then here it's already solved for 0. Okay, so you're going to leave it at x equals 0. So the factor form, I'm going to start with y equal a times x plus 2. And because it's a double, I need to square the factor. And because I have a single, I'm just going to write x, okay? Because x is by himself, I'm going to bring it in front. So I'm going to write y times ax times x plus 2, everything squared. So to identify what a is, I need to pick a point on the polynomial. I need to pick a point on the polynomial, any points. But I don't want to use decimal, okay, for points. So I'm not going to use this point right here, but I'm going to use the point right here, this point right here. And this point is its order pair is -1, +1, which means I'm going to replace the x with -1 and the y with +1. So wherever I see 1, I'm going to put +1, okay? And I'm going to leave the a alone, okay? Okay, so what I've did here, I replaced y with +1, okay, and x with -1, okay. So after doing this, what I've done is I multiply -1 plus 2 is +1, and you square it, you get what? You get +1. And +1 times -1 is -1 times a is going to be -1a. And I want to solve for a, so I'm going to divide by -1 on both sides. Okay, so then I can now replace my a with -1. That's what I did here. And then -1 times x, which is going to be -x, times x plus 2, everything squared. So what is going to be the standard form then? So the standard form is not that difficult since I already have the factor form. We all have to expand the power of 2 in terms of factors. So exponent of 2, tell me how many times the base needs to be multiplied by itself. So here the base is x plus 2. So I need to multiply the factor x plus 2 by itself twice, like I'm doing right now. Then I have to multiply by using the distributive property or the box method. So I'm going to here use the box method, but you can use the distributive property. So what I'm going to do here, I'm going to multiply those two terms together right here, okay? Okay, so I multiply the first factor x plus 2 times x plus 2, x times x, x squared, x times 2, 2x, 2 times x, 2x, 2 times 2, 4. And we notice you can combine the two diagonal terms. So I end up with x squared plus 4x plus 4. So then I can continue y equal -x times x squared plus 4x plus 4. Because here is only one term, I'm going to take that -x and multiply with the x squared, with positive 4x, and with positive 4. So I end up with y equal -x cubed, okay, minus what? Minus 4x squared minus 4. And this is the standard form. Okay. Now, what is the domain? Again, as you can see, you see how the line of a polynomial, of this polynomial, is continuous, right? There's no break, neither gaps. So what can you conclude? It means that x can be any real numbers. There's no restriction on what x can be. So the domain for any polynomials is going to be all real numbers, okay? So all real numbers, that's in word. Okay, but I want it in interval notation. So you're going to start with the parenthesis, -infinity, comma, positive infinity, and close the parenthesis. And for infinity, when you write in interval notation, always use parentheses, never brackets, because of the definition of infinity. Infinity keeps on going forever. There's no a fixed number for infinity, okay? Infinity can be any number. So you want to leave it open, so that's why you put parentheses. And the range, again, the y value, the lowest y value that this polynomial can have is going to be what? Remember, the arrows mean the line keeps on going down forever. So you can go from -infinity, the y value can form up to, and the line on the right continue to go up forever too, right? So from -infinity up to positive infinity. Again, all real number as well. And that's it. I hope this video was beneficial to you. So thank you for watching my video. Have a wonderful day and see you into the next one. Bye-bye.